Yep. Yeah, I'm going live. Good afternoon, y'all. Good afternoon. Good afternoon. Good afternoon. Hi, Miss Eastside. Good afternoon, Randy and Tiana and Sean. Good afternoon, Lamia, Malik. Good afternoon, Elizabeth. Good afternoon, Darren. I hope I didn't forget anybody or I didn't miss anybody. Good afternoon, you all. I'm glad you're here on time. For today's lesson, you're going to need the week 4 packet and the week 6 packet. We did the week 5 packet 2 weeks ago because it made more sense to teach that first than to teach this. So again, you're going to need your week 4 packet and your week 6 packet. Good afternoon, Isaiah. Good afternoon, Kwalik. Good afternoon, Torian. All right, as you join in, make sure you have your week 4 packet and your week 6 packet. Your week 4 packet and your week 6 packet. If there's either of those packets that you do not have, it is okay because, again, the questions will be on the screen. You can write them down on a sheet of paper. Make sure you have something to write with and something to write on. Good afternoon, Amaya. We're going over the last part of that week 4 packet today, and we're going over the beginning of the week 6 packet. Again, make sure you have those. Thank you, Kwalik, for getting right to work. All right, warm-up question number 1. If I wanted to trace the descendants of a species, I might create a what? Good afternoon, Tyler. Go ahead and type your answer in as you join. Good afternoon, Sanaya. Thank you, Lisbeth. So I have 2 answers so far. If I wanted to trace the descendants of a species, I might create a fossil record, B, a cladogram, or C, a Punnett square. I have 4 A's so far. Thank you for those of you who are getting right to work. Again, thank you for those of you who are getting right to work. Good afternoon, Aaliyah. Good afternoon, Amani. Good afternoon, Destiny. Great job. Thank you, Amani, for getting right to work. And again, thank you, Sanaya. You're going to need your week 4 and your week 6 packet. If you don't have that in front of you, go ahead and get those now. Again, your week 4 and your week 6 packet. If you don't have either of those, it's okay. The questions will be on the screen. You can write them down on a sheet of paper. Make sure you go get something to write with and something to write on now if you don't have those packets. All right, I have seven answers. Okay. I have 7 answers so far. Moving on to warm-up question number 2. What is the fossil record? Warm-up question number 2. What is the fossil record? Type your answer in the comment section. Type your answer in the comment section. What is the fossil record? We talked about the fossil record last class on Wednesday. What is the fossil record? Type your answer in the comment section. Good afternoon, twin. Good afternoon, Genesis. Go ahead and type your answers in the comment section. You're going to need that week 4 and that week 6 packet. Remember, we did week 5 2 weeks ago. I have 4 answers to the warm-up question, 5 answers so far. Thank you, Avion. Thank you, Amani. Thank you, Randy. Thank you, Lamia. Thank you, Tiana. Thank you, Kwalik. All right, moving on to warm-up question number 3 in about 10 seconds. If you haven't typed your answer in for question 2, go ahead and do so now. All right, thank you, Lisbeth. Question number 3, what techniques is used to tell how old a fossil is? What technique is used? I should say technique, I'm sorry. What technique is used to tell how old a fossil is? A, estimation. B, timelines. Or C, radioactive dating. Good afternoon, patients. Again, what technique is used to tell how old a fossil is? A, estimation. B, timelines. Or C, radioactive dating. Type your answer in the comment section. I have 1, 2. I have somebody thinking about it. Elizabeth, I'm glad to see you're back. I have somebody who tried. I love it. Great job. 3, 4. I'm at 4 answers so far. Giving you all about 20 more seconds to type your answer into this question. What technique is used to tell how old a fossil is? A, estimation, B, timelines, or C, radioactive dating? Okay, Torian, I for right now, I'll accept either or right now. Thank you, Destiny. Thank you, Lamia. And again, for those of you all who just joined or those of you all who might have missed the announcement, we're working out of that week 4 packet first today. We're going to finish up the end of that packet, and then we're going to start on that week 6 packet today as well. So make sure you have both of those in front of you. If you don't have either of those, it is okay. I will be showing all the questions on the screen today. So make sure that you have something to write on and something to write with. All right, moving forward. Thank you, Lamia. Thank you, Sanaya. And last question, question number 4. What is the equation to calculate radioactive dating? Now, you can find this in your packet where we left off. If you go into the week 4 packet and you go on to the first page that says math connections, the equation for the radioactive dating is in that set of directions. Type your answer into this question here. This is actually going to be helpful in getting us jump started. I have 1 answer. Thank you, Kwalik, for being on top of your stuff. I'm going to give y'all some wait time. Again, what is the equation to calculate radioactive dating? If you go in your week 4 packet and you go to the first page that says math connections, you will see the equation on that page. I have 2 answers. Yes, ma'am, you can. I'm going to see if somebody else can join first because I have somebody going over something with us. And then I'm going to add you in. All right. Good afternoon, my love.
Hey.
Okay, so we're going to get started. So we're going to go back first, jump into what it is we're doing, and then we're going to jump forward. So again, we're in that week 4 packet right now, and we're towards the end where it says math connections. The last 5 pages of that week 4 packet is what we're focusing on. That's where we left off. So by the end of this lesson, can you break this objective down for us, please?
Yes. You want me to read it first?
Yes, please.
By the end of the lesson, doctors will be able to explain and analyze the fossils records and what is that?
Paleontological
Techniques in order to evaluate the data from the fossil records and validity.
Validity. Good job. How many verbs do we have?
3.
Beautiful. All right, what's the first verb?
Explain.
Great job. What does it mean to explain?
Is it to show?
It's not to show. So typically, our job is to explain stuff to you all day, every day.
Oh, so you teach us.
To teach. Great job. Thank you for those helping out in the comments. To explain is to teach. What's the second verb?
Analyze.
All right, and what does it mean to analyze?
To break down.
Great job. And then last verb?
Evaluate.
And what does it mean to evaluate?
To tell.
It's not to tell. Explain was teach. Analyze was break down. Evaluate. So when you go, if you look in the comment section, somebody's trying to help you out. But when you go into a courtroom, there's somebody there whose job it is to evaluate all the evidence presented and come up with a result. A judge. Good job. So to evaluate is to judge. So can you give it to us now with the definitions in place of the verbs?
Yes.
Thank you.
By the end of the lessons, doctor will be able to teach and break down the fossil record and I never can.
You got this. Paleontological
Techniques in order to judge the data from the fossil records and validity.
Good job. All right, so pretty much we're trying to be able to break down what the fossil record is and prove that all the information and data that's in the fossil record is actually valid, it's legitimate. So last time we were in class, we left off at the math connection. So I'm going to review real quick, and then we're going to jump into what we did. So one more question. One is that if I wanted to trace the descendants of a species, I might create a what? What was the answer to this question?
A B.
B was correct, a cladogram. You would create a cladogram. You can't create a fossil record. The fossil record is something that exists and something that we add to as we find more fossils, but it's not something that you can just go and recreate if you need to show where somebody came from. So the correct answer for question 1 was B. Question number 2, what is the fossil record? What answer did you have?
I had C.
You had C. That is correct. A comprehensive data on every fossil ever found. The fossil record, again, has information on every fossil that's ever been discovered, and it helps us to kind of trace and track down where things came from and what lived on Earth. Question number 3, what technique is used to tell how old a fossil is?
I didn't know this one, so I just thought it was like a C or B.
Okay, and C was the correct answer. So I know a lot of you all were confused between B and C. I'm glad most of you all did not say A. So yes, we do use timelines to keep track of when certain things live, but in order to actually tell how old something is, like if you have the actual fossil or you have the rock that it came from in your hand, you could radioactively date that specimen right there. You take some of the chemical, you burn it, and you analyze what chemicals are released from it, and that's called radioactive dating. And you can pretty much calculate the half-life of those chemicals. Now, the picture right here shows you radioactive dating. So let's say we find the fossil, we take that fossil age, we take that fossil, we burn it, and then we analyze the chemicals that come from it, and then we calculate the amount of chemicals present and how much of that chemical has decayed, and that we can use that in a mathematical equation right there. So that leads us to question 4. What is the equation to calculate radioactive dating?
It was B.
All right, so you said B, and that was correct. B, y equals 1/2 raised to the x power. So now we're talking about exponents. It wasn't just multiplying the two, you had to actually raise it to the exponents. So make sure that you all are keeping up as we go in. Good afternoon, my love. All right, so I'm going to be adding more people as we go through, but first off, I'm going to ask Tiana to guide us through what we went through last time. So last time, we did these problems here, and I'm pulling the problems that are on the worksheet, and I'm just showing them to you in a PowerPoint format. So if you look, this was the first page in your math connections section of your science packet. I just pulled it into the PowerPoint so I can type on it. So Tayan, I'm going to read the directions, and then I'm going to ask you to guide us through the first 2 questions, okay?
Okay.
All right, so radioactive dating is a technique used to date specimens of igneous rock. Elements vary in form based on the differences in the number of neutrons in the atom's nucleus. These various forms are called isotopes. Some isotopes are radioactive and can be used to date rocks using their known half-life, the amount of time for the original number of atoms to fall or to half its original value. Different minerals contain different radioactive isotopes. Once the rock has cooled, radioactive decay begins, and the original or parent atoms begin to decay and form daughter atoms. The parent-to-daughter proportion of atoms in a substance can tell us how many half-lives have occurred. The number of half-lives is multiplied by the length of one half-life, and the age of this substance is revealed. I'm going to read that sentence one more time, and I just read that last sentence at the end of the second paragraph. The number of half-lives is multiplied by the length of one half-life, and the age of the substance is revealed. The chart below shows the parent isotopes, daughter isotopes, and the half-life of the parent isotopes. So in this case, for these problems right here, we are multiplying the number of half-lives by the length of one half-life. So question number 1, Tiana, we set it up last time, but can you walk us through how you solved it?
Okay. First, I read the question, and then I took 0.058 and times it by the half-life of is it argon, right?
Yep.
And it was 1.25 billion years.
Good job.
And then I got my answer.
Okay, and what answer did you get?
7,250,000.
Okay. So that's the answer you got. That's what you're saying?
Yes.
Okay. Did anybody get anything different? Good afternoon. Did anybody get anything different for question 1? All right. I'm not seeing anything in the comment section, so I'm guessing we all got the same answer. Make sure you have that answer written in for question 1. Again, she took the number that was, yes, we're on the page. It says math connections. She took the number that was actually in the problem, the 0.058, and she multiplied it times the number of half-lives, which was 1.25 billion. When you write 1.25 billion out, this is how it looks. And when you actually solve the problem, when you multiply those two numbers, this is the answer you get. All right. Moving forward to question number 2. Can you break down question number 2 for us, please?
You want me to read it? Or explain?
You can read it, or you can just tell us how you did it.
Okay. So basically, I took 0.89 from the half-life, and then I multiplied it from the, what did I multiply? Okay, from the uranium.
Okay, so this one right here, or this one right here?
Which is
Which one are you talking?
the lead.
The uranium and lead. Like lead
Yeah,
in the
lead.
pencil. So uranium and lead. Okay, so 4.74 billion.
And I multiplied those together.
Okay, so again, she took the number out of the problem, 0.89, and she multiplied it against the half-life of the parent, which is 4.74 billion. That's written out here in the long way. What answer did you get?
I got 4,298,600,000.
All right. And that's the answer she got. Great job, Tiana. All right. Anybody need help with question 1 or 2 before we move forward? If you're ready to move forward, send me a thumbs up. If you need me to go back or you need Tiana to go back, send us a thumbs down. Thumbs up if you're ready to move forward. Thumbs down if you need help. And if you do need help, tell us which one you need help with, 1 or 2. All right, we got 1 thumb up. 2 thumbs up. 3 thumbs up. Okay, seems like everybody's been able to keep up so far. Okay. If you do need help as we go through, please do not hesitate to put the number that you need help with in the comment section, and either one of your peers will help you, or we will pause where we are and go back and assist you. Do not hesitate. Do not be afraid. Do not be embarrassed. The next part, and now I'm going to the second page in the math connections portion. It looks like this. We started this last time. Tiana's going to break it down for us, and then Tiana, I'm going to actually push you to help us fill in the first 2 columns as well, okay?
Okay.
So I'm going to read the directions, and then I'm going to ask you to explain how you solve this last column and give us the answers, and I'll fill it in. So it says the parent to daughter proportion of atoms in a substance can tell us how many half-lives have occurred. To calculate the fraction of original parent material left in a specimen, you can use the number of half-lives. Y equals 1/2 raised to the x power, in which y is the fraction of original material and x is the number of half-lives. So again, y to the 1/2 x power, in which y is the fraction of original material. That's this column right here. And x is the number of half-lives, this column right here. Use the equation above to calculate how much of a parent isotope is left based on the number of half-lives experienced. Assume that there are 100 parent atoms in the original specimen. So they gave us the first 3 for us, and we have to fill in this column first. Once we fill in the 4th column, then we'll be able to fill in the 1st column, and then from there the 2nd column as well. So Tiana, can you walk us through how do we do that?
Okay, first for the first one, which is number is it number 3?
Yes.
You want me to tell my answer first, or explain how I got it first?
Explain how you did it and then tell them the answer. And I believe we went through that together as a class last time, so a lot of people should be able to keep up with you. Go ahead. Okay.
So basically, I moved x and I put 2 for x.
Okay. So you ended up solving y equals 1/2 to the second power. Is what
Yes.
you're saying? Okay, and what answer did you get?
1/4.
You got 1/4. So 0.25 or 1/4. So I'll put it in fraction format so that we are all consistent. If you have 0.25, that's also fine. All right. So what did you do for the next one? For number 4?
Huh?
What did you do for number 4?
I did the same thing, except if you wanted to do it easier, I just times 1/4 times 1/2 because it's going up 1. So I just times 1/4 times 1/2, and I got 1/8.
All right. So if you raise, you're telling me if you did 1/2 to the third power, you got 1/8. That's what you're saying, right?
Yes.
Okay. So we got 1/8 for the next one. What about the number 5? This row right here.
Huh?
What about number 5? The row right here. How do we solve it, and what answer do we get?
I got 1/16, and I solved it by doing 4/1/8. 1/2.
All right. So she did y equals 1/2 to the fourth power and got 1/16.
Yeah.
All right. Then keep going. What did you do for the next one?
Just put 1/2 raised to the 5th power.
Okay. Great job. And what did you get?
1/32.
1/32. And then keep going down.
1/2 raised to the 6th power. And I got 1/64.
1/64. That's okay, Clara. Thank you for telling me that. 1/64. Okay.
Mm-hmm.
All right. So they gave us the first 3. They gave us 1 3/4 and 1/2, and then Tiana gave us for number 3 in the last column you should have 1/4. For number 4 in the last column you should have 1/8. For number 5 in the last column you should have 1/16. For number 6 in the last column you should have 1/32. And then for number 7 in the last column, you should have 1/64. So now we have to start doing a little pattern recognition and figuring out how we fill in those first 2 columns. So the thing about the first 2 columns, Tiana, is they build on each other. So if you pay attention to the first column and the fourth column, when we were at 1/2, we were at 50 in the first column, correct?
Yes.
When we were at 3/4 in the last column, what do we have in the first column?
75.
75. When we were at 1 in the last column, what do we have in the first column?
100.
100. So stay focused, y'all. So if you pay attention, the fraction in the fourth column corresponds with the number that should go in the first column. So 1 is 1 whole, so that's equal to 100. 3/4 of 100 is what?
Huh? You said it again?
3/4 of 100 is what?
75.
75. Stay focused, y'all. 1/2 of 100 is what?
50.
50, and that's how they got the 50 here. So what is 1/4 of 100?
25.
25. So for number 3 in that first column, you should have 25. 25 goes right here in that first column. Elizabeth, stay focused, my love. Stay focused. Keeping it moving. What is 1/8 of 100? If we divide 100 into 8 parts, what will we get?
Divide 100 into 8 parts. Let me see. Do you want me to divide 8 divided by 100?
You can do it 2 ways. You can divide 100 by 8, and that'll give you the answer. Or if you notice, 1/8 is what compared to 1/4?
Bigger, right? No, smaller. 1/8 is smaller than 1/4.
Kalara, stay focused. So 1/8 is smaller than 1/4 is correct. But if you had to compare it, 1/8 is what portion of 1/4?
Can you say that again?
1/8 is what portion of 1/4?
I think it's a half.
It is.
Yeah,
It's
a half.
1/2 of 1/4. So you could technically just divide this number in half too. That's the easier way to do it.
Can we do that?
Okay. All right, ladies, stay focused. Stay focused. Ladies and gentlemen, stay focused. You all should be in the comment section helping Tiana figure out how to solve these problems.
Is it 1.25?
Okay, so it's not 1.25. 25 divided in 2 is what? Your numbers are right. Your decimals in the wrong place.
12.5.
Good job. 12.5. 12.5. All right, and let's keep it going. So again, now we got to figure out what is 1/16 of 100. What's 1/16 of 100? Thank you, Randy. Good job.
You have to divide it by 100. 16 divided by 100.
No, 100 divided by 16.
Oh yeah, 100 by 100. Okay, I always get that mixed up. I always put 16 first.
This is back and forth, Imani. Yes. We're at the end in the section that says math connections. We're on the second page of the math connections part.
Okay, hold on, give me a minute.
All right, so I like the fact that you all have come to a resolution with this whole back and forth. It's done. It's dead. Move forward. Let's go. Focus. Stay focused. And no problem, Imani. You all should be helping Tiana out. If you divide 100 by 16, what do we get? If we divide 100 by 16, thank you, Genesis. Great job. 6.25. 6.25. All right, let's keep it moving. What's 100 divided by 32? What is 100 divided by 32?
Divided by 30.
What is 100 divided by 32? Good afternoon, Miss Proctor. Hundred divided by 32. Great job, Kwalik. 3.125. 3.125. And if you all start paying attention to the patterns, from this point forward, all we're doing is dividing the number in half. You divide 25 in half, you get 12.5. You divide 12.5 in half, you get 6.25. You divide 6.25 in half, you get 3.125. So the last number, if we divide 100 by 64, we'll get this answer. Another way to get this answer, we could also just divide 3.125 in half. What is our final answer? What is 100 divided by 64 or half of 3.125?
Miss Smith, I think Elizabeth got it. It's Elizabeth. Sorry, I always pronounce her way wrong.
It is. Great job. Thank you, Elizabeth. It was a lag in mine. I don't know how you saw it so fast. All right. Thank you, Elizabeth. Thank you, Sanaya. 1.5625. Great job. 1.5625. All right. So, again, that last column helped us figure out the first column. Now, the second column, we're going to use the third column to help us figure out that second column. And again, it kind of goes with pattern recognition. So, if you look at the second column, Tiana, right? The first number we have in the second column is a what? What's that first
0.
number? A 0. Great job. 0. So you notice there's a 0 number of daughter atoms is a 0 half-life. Now when we keep going, if we go to 0.4, right? 0.4 is about 40%. 0.4 is very close to 0.5. So if you go to 0.4, 0.5, or half of a half-life, we get 25 daughter atoms, right?
Mhm.
If we go one complete half-life, we have 50 daughter atoms. Okay?
Mhm.
So one complete half-life gives us 50 daughter atoms. If one complete half-life gives us 50 daughter atoms, how many would two half-lives give us?
100.
Great job. How did you get that?
Because all I did was add another one, because if that one is 50, all you do is add another one and we'll get to
Great
100.
job. So if one half-life gives us 50 and we need two, you just add another 50 on, you get 100. What about three?
150
Great job. Keep going.
and 200,
200. Keep going.
250,
250. And
and
then
then
last
last
but
one.
not least. All right, Tayana, fantastic job.
Thank you.
All right, so stick with me for a little bit longer. So now they ask you to take that data and to put it into a table. They ask you to take that data and put it into a table. Before I switch to the next screen, is anybody still need to see this screen here? If you're ready to move forward, send a thumbs up. If you still need to see the screen, send me a thumbs down. If you're ready to move forward, send me a thumbs up. Thank you for being supportive of your peers. Thank you, Kalera. Thank you, Imani. Thank you, Sanaya and Randy and Kwalik. Thank you, Lisbeth, for helping to contribute to the answers that we put on the table. Thank you, Tayana, for being perseverant. Thank you, Isaiah, for staying positive. All right, we got 2 thumbs up, 3 thumbs up. Thank you, Lamia. 4 thumbs up. All right, seems like we're ready to move forward. All right, so Tayana, we have to take this information and pretty much put it in a graph, right? So they asked us to compare 2 things. The first part is a plot on the graph below the relationship between the number of parent atoms versus the number of half-lives. So we're talking about the first column in your table, the number of parent atoms, and the third column in your table, the number of half-lives. So they're asking you to plot this versus this. So as the number of half-lives increases, what happens to the number of parent atoms?
It goes down.
It goes down. So what that would look like is as this goes further away, as we go further away from here, we should be coming down. You should have a line that comes from the top up here
All the way to the
and
bottom.
goes down for your parent line. And whatever line you do for your parent, make sure you distinguish it and mark it in the key. So if you do a bold line, for your parents, or a dotted line or some kind of squiggly line for your parents, that's fine. Just make sure you put a note about what kind of line you did for your parent in the key section over here. But again, the line for your parent should be coming from the top up here and going down.
Okay.
Now it also asks you about the number of daughter atoms versus the half-lives. And Tayana, when it comes to our daughter atoms, what was the relationship?
The relationship?
Yep. How did the daughter atoms compare to the number of half-lives? As the number of half-lives increased, what happened to the daughter atoms?
It got bigger.
It got bigger as well. So for the daughter atoms, you have to use a different type of line. So for my parent, I might use a really, really thick line. For my daughter atoms, I might use a thin line on my graph. Now, our daughter line should be coming from the bottom and going up. It should be going up, starting from 0 and working its way up. So the parent line should be going down from 100. The daughter line should be going up from 0.
Or we can just add an arrow at the end of each line to know the
You
difference.
very much could. So now we are on page 3 of the math connections portion in the week 4 packet. And the page looks like this. All I did was just take a screenshot and put it on a PowerPoint. Yep, question number 8. All right. So now question number 9 asks, describe the relationship on the graph. Are they linear? Are these lines linear? Meaning, do these lines pretty much continue in the same pattern?
Yeah.
Yes. So they are linear lines. So for number 9, the answer is yes, they are linear. Yes, they are linear. If they weren't linear, then you would see the lines kind of go up and down, maybe stay straight for a little while. but they continue to go in the same direction. Like Tiana said, you could put arrows on them because they continue in the same way the entire time. And then number 10, Tiana, how does the number of parent atoms compare to the number of daughter atoms?
The parent atoms go down and the daughter atoms go up.
Great job. So as the parent atoms decrease, the daughter atoms increase. So for number 10, as the parent atoms decrease, the daughter atoms increase. Okay. Tiana, we're going to move forward, all right?
Okay.
So in your packet, and I didn't put this in PowerPoint format because it was just too much to show. In your packet, there's a page that looks like this. It says Evolutionary History and Relationships. This page here, ladies and gentlemen, is extra credit. If you do it, great. If not, it is okay. I'm not holding it against you. This page here was designed to give you more practice with math, but it doesn't actually relate to a technique that scientists use. Radioactive dating is a real thing that scientists actually use, so I wanted to make sure we went over that. But this here, they literally took a bunch of different math equations and they turned it into somewhat of a puzzle for you all, which is really cool when I did it, but it was also very tedious, so we're not going to do it on the live. But pretty much you use page number 2 right here, the page that looks like this, to solve this table here. And you would go problem by problem. So you go through here first. So the first animal they gave us was the American robin, right? So if we go to this second page, does the American robin fly, Tiana?
Yes.
Okay, so it has the ability to fly. So we would go with A, flying, right? So then we solve this problem here. So x minus 21 equals 36. What would x be?
X?
Thank you for the time check. Just for those of you all who need to know, I'm probably going to go up until 150, 155. So just stick with me for a little while. So if x minus 21 equals 36, I need you to solve for x. What would x be?
X would be 57.
You're correct. X would be 57, right? So then we go down to whichever problem says x is 57. That would be this one. So x equals 57. Body covering. What is that American robin covered in? Feathers or not feathered?
Feathers.
Feathers. So then we would then solve this problem here. And it would continue on. So you just keep solving problems until you get to where it gives you a scientific name, right? And then you write that scientific name in the box. If you all would like to try this and you need help, I have no problem working with you either one-on-one or answering any questions. Just direct message me. But again, this is tedious, so we're not going to do it on the live, and it's also not a real scientific technique. This one here is also not a real scientific technique. They actually took a cladogram or the shape of a cladogram, and they want you to practice using like terms. So if you combine the equation here and you combine the like terms, once you break or you simplify the equation, it'll end up being one of the equations at the bottom. And then all you have to do is pretty much write down the name underneath the equation, right? So we're going to do the first one just to model it, but then we're going to move forward. So the first one, let me see if I can zoom in because it's kind of small. Okay. All right. So the first one says 2x plus 3y equals 2y minus 4x plus 3. Okay. So we want to get the y on a side by itself. We want to get the y on a side by itself. So how would we start this, Tiana?
First, we will combine like terms.
Okay. So which term am I going to combine first?
Huh?
Which term would I combine first? Or which terms?
Well, I don't think we can combine like terms right now. I'm saying.
You can. You start. Yeah, the first step that you just said was right. You can combine terms so far. So we want to get this y on the side by itself. When I look at it, I would say that it would be easier, in my opinion, to get this y by itself than this y by itself because you have two other terms on this side, whereas on this side you only have one other term. Right. So if we need to get this 2x on this side, what do I do to this 2x?
Reduce it?
You can't reduce it. Is it positive or is it negative?
It's positive.
It's positive, so you would do the opposite. So you would
So you
subtract the
subtract it
2x
back.
from this side.
Okay.
And then whatever you do on this side, you have to do on this side. So when you take 2x from this side, what do you end up with on this side? Or when you put a negative 2x on this side, what do you end up with?
For which one?
So if we take this 2x that's right here, right?
Mm-hmm.
And we make it negative. If we subtract it from this side, then it cancels out on this side of the equation, right?
Right.
But now we have what we do on one side of the equal sign, we have to do on the other side of the equal sign, right? So if we take this and we put if we put a negative 2x here, we have to put a negative 2x here.
Right.
So we have a negative 4x and a negative 2x. So what does that become?
A positive 6x.
It wouldn't be positive. It would still be negative, but it'd be negative 6x.
Negative would be a negative. Yeah.
Okay. So now we have a negative 6x, right here. We have to get this y by itself. What is this y? How many y's do we have?
2.
And try again on this side of the equal sign.
Oh, 1.
He should have, Elizabeth. So on this side, we have 3 y's. So it says 2x plus 3y, right? So
I'm talking about the single one.
Yeah, the side we're trying to get by itself. So we need to move this side over because it's smaller. So we have 2y here. So we're going to divide by 2y here, divide by 2 here. Got it? Or we'll subtract 2y from this side, and then we'll subtract 2y from this side. So how many y's are left?
Just a singular y, 1 y.
Just 1 y. So you end up with negative 6x. Y equals negative 6x plus 3, I believe. And that gives you that first one right here. So again, this is just a way to get you all to practice your math skills, but it's not an actual scientific technique. So I showed you how to do one. And again, if you want to go through and do the rest of the worksheet for the extra credit points, that's fine. If you need help doing it, I have no problem with working with you in a direct message on it. But it's not something we're going to spend a lot of time on the live doing. Your week 6 packet, if you quickly go to your week 6 packet for a split second, because we don't have a lot of time. Thank you, Kamira. Good job. All right. So if you go to your week 6 packet, your week 6 packet talks about artificial selection. The goal for us right now is to get you through the week 6 packet by the end of this week, so we can be on week 7 and week 8 next week. And then you only have, after today's lesson, 4 more lessons. So your last lesson will be spent on week 9. Artificial selection, I'm going to point out a few things before I will give you all your homework for today. Artificial selection encompasses selective breeding as well as genetic engineering. So when I say selective breeding, artificial selection is not natural selection. So in natural selection, you have environmental pressures that cause certain species to grow and develop and thrive, and they're able to reproduce, whereas other species die out. That was natural selection. This is not that. Artificial selection is man-made selection. So in this picture that they gave you here of artificial selection, you have 2 types of corn, and one of the corn is able to do really well in a drought. So they were able to take that corn and they were able to crossbreed them or make them have babies, make them mate and have offspring. And then they ended up with corn that now does well in a drought. The offspring can now survive a drought. So in artificial selection, in artificial selection, they pretty much take parents that have traits that they desire, and they have the 2 parents make a baby so that they can have a baby that has the traits that they want the baby to have. So again, that can look 2 ways. They can either do selective breeding. So if I wanted a mix between a sheep and a goat, I might make the 2 of them have a baby, and I'll end up with this creature here. And you can use genetic engineering and actually go into the genes of an organism and change those genes so that they come out with the trait that you want them to have. Now, in the beginning of your week 6 packet, they ask you 2 simple questions. They start off by saying, can you generate possible answers to the question above? And the question they asked was, how can humans pick traits of organisms? They can pick the traits of organisms by either using selective breeding or genetic engineering. Again, they can pick the traits of organisms. This is page 1 in the week 6 packet. Page 1 in that week 6 packet. They can pick the traits of organisms by using selective breeding or genetic engineering. And then question number 2 says, make your own questions about the phenomena. You can create any question you would like about either genetic engineering or selective breeding or artificial selection to write down for question 2. But for question 1, you should have, they can use selective breeding or genetic engineering. I'm going to explain the next set of questions that they ask you, and for homework, you all are responsible for doing it. So these questions here are on that second page. Let's see if I saw it. So this is page 1. I'm sorry, it's on the first page. So this page here is what I'm talking about, your week 6 packet. You are doing these 4 questions or these 4 parts right here. And I think you only need to write answers for 3 of them, realistically. Looking at these images, the 2 images they gave you, this is the African wildcat right here. This is a domesticated cat. It is actually a Siamese cat. That's the kind of cat they're showing you. It's a Chinese cat. It has Chinese origins. Here I added 2 other pictures of the same type of cats. The African wildcat, the Siamese cat. They're pretty much trying to say, the picture on the left of this African wildcat, it shows the ancestor of the domesticated cat. So they're saying this cat came from this cat. Now, Tayana, I'm going to ask you, it says, if you wanted to crossbreed some of the African wildcats, right? And you wanted to eventually end up with this cat here. So if you wanted to breed this cat so that you ended up with this cat, what would you have to change about the wildcat? What's the differences between the 2?
You have to change the species, right?
So eventually we would end up with a new species, but what are some of the traits or some of the differences that you can see just by looking at the 2 cats?
They are different colors.
Okay, so we'd have to change the color of the fur. What else do you notice that's different?
Their eyes, like, the one on the
You kind of went in and out there one time.
The one on the left eyes is like smaller, and the one on the right eyes is like bigger.
I think you got to repeat it. Okay, so the shape of the eyes, you're right. Good catch. I didn't catch that. All right, so you have to change the color of the fur, the shape of the eyes. I also noticed that you have to change the eye color. The Siamese cat has blue eyes, whereas the African wildcat seems to have like a gray eye or maybe a dark green eye. There are a lot of differences. So for that first question, you all are going to have to point out some of the differences that you notice between the 2 cats. That second question says, how have humans changed species through breeding? So what did you tell me at first when I said if I wanted to end up with this one from this one? You said I had to do what?
Change the species.
I had to change the species, right? So how have humans changed species through breeding? In order to answer that question right there, you are going to have to point out how they have made these 2 cats, again, different. So point out some of the differences between these 2 cats. And then for the third question, what are the potential benefits of this type of experiment? So what would be the benefits of being able to create a baby or an offspring?
There would be a new type of cat.
There would be a new type of cat, and what would be the benefit of creating this new type of cat?
To have more so they won't die out.
Okay, so how would you keep it from dying? Now y'all are getting me somewhere, but y'all are stopping short. So Kamara, same thing, Elizabeth. If you're, yes, there's a different culture. Yes, there's a different species. What is the benefit of having a cat that's of a different culture or of a different species?
They can have both of the traits from each.
Okay, so they have both of those traits. Keep going.
And I don't know what else. I think it's gonna be like a different kind of cat, more cats.
Okay, so let me pose this question to you. Do you think this cat can survive in Africa?
No,
Okay, why not?
because it's from China. Like, isn't it from China, right?
So this cat has Chinese origins, yes, but it essentially its ancestor is from Africa.
Okay.
So do you think it can survive in Africa?
No, because it's like originally from China, but since it's like made Africa, it should be able to.
Okay. So Genesis pointed out they would have different behaviors. Yes, they'd have different behaviors. Kamira and Elizabeth pointed out they'd have different genes, and y'all are getting me there, but y'all are stopping short. Y'all got me like 73% of the way. I just need that last 27%. So with those different genes, with those different behaviors, being in the fact that now this cat lives in China, what are some things that, why would it be beneficial to have a new cat as opposed to having this
They would
cat?
be able to survive in both.
Okay, there we go. Now we're getting somewhere. So, what are the potential benefits of this type of experiment? You could create a species that can survive in multiple environments. So, again, you can create a species that can survive in multiple environments. So, now I have a cat that might be able to survive in Africa and China. They do this all the time with your food as well. So, a lot of the food that we eat has been genetically engineered or has been artificially bred in a way that it can now survive drought when it's growing in a farm, or it can survive different pesticides. So now they get to use all these strong chemicals on the food while it's still growing on the farm, and the food will not be killed by these pesticides because genetically it can withstand it. So the answer to that question right there is now you can create a species that can survive in multiple environments. Yes, Elizabeth, they take the two genes from the different animals and make a new creature. So they might take, and it might not even be two genes. They might just take one gene from one animal. So in some cultures, what they do, or some instances, what they've done is they have spiders that, of course, can weave silk, or they have silkworms. I'm sorry, they have silkworms that can weave silk fibers, and they took the gene in a glowworm that makes the glowworm produce fluorescent colors, and they were able to take that gene and put it into that silkworm and make it so that the silkworm's fibers are now fluorescent. They now glow in the dark. So they were able to then take that silk that the silkworm made and make fashion out of it. That's not nasty. Tyon, what were you saying?
She had went somewhere.
Oh, okay. So again, if you did not answer all three of these questions, please answer these three questions. And when we pick up on Wednesday, we're going to be going through the remainder of the week 6 packet. Please try and fill in what you can in the week 6 packet, so that way as we go through, we are pretty much just checking answers and helping to clarify certain things that you may not have understood. I'm also going to post a video tomorrow morning to help you all or guide you all through the week 6 packet, the same way I did with the week 4 packet. And I'm going to post some extra materials that you all can go through to help you understand this information. Does anybody have any questions or need any assistance? Anything that you need me to clarify today before we go off of the live? Please make sure also that you all go ahead and enroll for next year. If you need the link, I'm going to go ahead and post the actual image of it on the class page, but make sure that you go ahead and have your parents fill out that enrollment for next year. If you do have questions, send me a direct message. I love you all. Please do not work your parents' last nerve. Get your work done. And if you would like to send pictures of your work to the class direct message, that's actually easier for me to give you the points than if you try and go turn it into the school. So again, send me pictures of the work once it's completed to the class direct message, so I can give you your points in the grade book. Chances are I'm probably still going to be teaching 7th grade next year, But you should still enroll, because we're working hard to make sure that you all have a really, really good eighth grade year. You said in what? But okay. I'm not sure what I missed. Come here, I missed something. What? Huh? Okay. If you have questions, send me a direct message. I love you all. Be great. I will see you all on Wednesday.